Hello, in this video we will learn how to calculate NPV and IRR for integer period cash flows. Now let me first tell you what are integer period cash flows. Integer period cash flows are those cash flows which occur on integer periods like 1, 2, 3, 4 and 5. And not only the calculation, we will also learn the interpretation of these two and the relationship between these two. In the next video, we will learn how to calculate NPV and IRR for non-integer period cash flows. That is, the cash flows which occur on non-integer periods like 1.5, 2.5, 3.5 years and so on. So let us begin with our example. We need to calculate IRR and NPV for a project involving cash initial cost of $100,000 and the cash inflows of 10,000, 25,000, 45,000, 30,000 and 55,000. The discount rate is 10%. Let's begin. So here are the cash flows and their times. So here we will use the formulas of Excel to calculate NPV and IRR. So let's start with the NPV first. Press N equal to NPV. We need to put the discount rate, which is 10%, comma. Now we'll put the value range, which is B3 to B8. As we can see, our NPV is $16,547.55. Now let's calculate IRR. Equal to IRR. We just need to get the value range only. As we can see, the internal rate of return is 15.58%. Now let's see the relationship between these two. For that, we need to prepare a graph, and for the graph we need some data. So let's place some data. Discount rate, which is going to be the x-axis, and PV, which is going to be the y-axis of the graph. So let's place the discount rate starting from 1% at the interval of 3%. 1%. Then 3 plus 1 4%, 4 plus 3 7%, then 10, 13, 16, 19. Okay, that's enough. NPV equal to NPV rate. For rate we will give this reference. For value range we'll give B3 to B8 again. And now before we copy this formula, we need to freeze this range. So that it does not get copied along with the formula. So to freeze this range, we need to press F4. Now let's just copy this. Let's check whether referencing is correct or not. Yeah, it is correct. Let's insert a graph. Okay, we'll insert this line graph. Looks good. So as we can see, the line is inversely sloped. So the relationship between discount rate and NPV is inversed. When the discount rate increases, NPV decreases. And as we can see, at some point it becomes 0 from between 15% to 20%. So this point at which NPV becomes 0, line touches the x-axis, this is the IRR. Somewhere a little higher than 15%, and we can see the internal rate of return is 15.58. Now what is the interpretation of NPV and IRR? The interpretation of NPV is very simple. If the NPV is positive, then the project or any financial investment is quantitatively viable. And as far as the IRR is concerned, every rate is compared to another. So internal rate of return is compared with the discount rate or required rate of return. In our example, the discount rate was 10%. Assume that this was the required rate of return. So since the internal rate of return is higher than the discount rate, so we can say that the project is providing higher return than what is required by the investors. So the project is quantitatively viable. So this is done for the video, and for the next video, in the next video we will learn how to calculate NPV and IRR for the cash flows occurring at non-integer cash flows. So if you like this video, then press the like button, subscribe to our channel and stay tuned for the next videos.